No matter what you're expecting this week, I promise you your head will be blown. Your mind will be expanded. This week, we're going to talk about the single most important topic in all of photography after your camera, and that is color. Getting color right. Technically, understanding color artistically, correcting color to solve problems, understanding how to read color, and so on. It's one of my favorite topics. I'm going to dig right in and then tell you too how it affects you in a huge way. I have a day job. I've told you about that. And one of my major customers is a magazine. It's a very famous magazine in the desert southwest of the United States. It's called Arizona Highways Magazine. And Arizona Highways Magazine has been around for nearly 100 years. They do 12 magazine issues per year. Times 100, that's about 1,200 covers. Now they know that as people go through the supermarket or the grocery stores or the newsstands, that it's whatever is on the cover that makes people reach out and grab spontaneously and pick up that magazine. And then they hope, of course, that they sell the magazine. It's become a very famous magazine, known for incredible photography. And the editor would kill me if I didn't also say in incredible stories. It has subscribers from 177 nations from around the world. It's a very popular magazine. It's sort of like the National Geographic magazine of the United States Southwest. At least that's what we say. Anyway, you can imagine Arizona is a beautiful place. I don't know if you've ever been there or seen photos, but if you were to come here, Arizona, my home state, and look around, you would say, oh my goodness, these photos are, photo ops at least, are amazing. And if you were to close your eyes and imagine what would be on the number one selling cover out of 1,200, the number one selling cover of all time, you'd think, oh, maybe the Grand Canyon here in Arizona. Now, some of these other phrases you wouldn't know. You'd have to Google them. Havasu, Havasupai, Havasupai Canyon, Sedona. Just the desert. It's incredible, but it doesn't matter. I'm not going to waste more time. No matter what you think would be the number one selling cover of all time, you would be wrong, even if you lived in Arizona. Let me show you what the number one selling cover of all time is, and what in the world does this have to do with today's talk? Okay, I look at that and I go, really? Really? If I were the photographer and I was handed a turquoise encrusted cattle skull and told to shoot that for the cover, I don't know what I would do. But I know that the famous photographer now who shot this most famous cover did exactly this. He knew something about real color. He made some great choices, and it impacted his business. And this cover from 1974 of January really has turned out to be their number one selling cover of all time. Now, there are some beautiful covers. I would think that would be one of them. And yet somehow it had impact. It had pizzazz. It had reach factor. It sold product. Their product. There's something about color that if you get it right, if I could bottle it and sell it, I would use it to my advantage. You, however, are at a very distinct disadvantage because, as you will see, you've been mistaught about color. You've been mistaught about color. Hey, let's discuss what I know that you certainly know. Let's just do the basics right away. And I want you to answer, even though you're watching this video, I want you to answer in your out loud voice when I ask this question. You know this. Let's just get it out of our systems, okay? If you ever had an art class, even in elementary school, middle school, high school, college, beyond, you know that there are three primary colors. What are they? What are the primary colors? Just say it on the count. 1, 2, say the primary colors. What were you taught? You were taught that the primary colors are obviously red, yellow, and blue. Everybody knows it. It's basic. It's fundamental to color. If you've ever taken an art class, that's what you know. Except that it's wrong. You've been mistaught. You've been mistaught. And you may not think it matters, but it matters to you greatly, and it matters to you in every photo you take. If it's a color photo, it matters in every photo you edit in post-processing, no matter what application you use. Lightroom, Bridge with Adobe Camera Raw, Photoshop. If you're at any other app you can think of, or plugin for photography, it matters. The truth of color will set you free. I'm going to show you why you've been mistaught. This is how you've been mistaught. This is famous. This is called the Munsell color wheel. The Munsell color system. It was well, here, let's just find out. I grabbed this, by the way, directly from Munsell.com. If I Google Munsell color, and I want it from Munsell.com, the official site, I'm typing that in, and I'm going to click on images, and let's see what makes, well, let's see. Number 1, the Munsell hue circle. That's it on a black background. Let me scroll down. Oh, there it is on a white background. It's the very image that I showed you on purpose. This is the Munsell color system. It was developed by Albert Munsell. More on that in a moment. You've been mistaught. Everyone knows that the opposite of blue, listen to me carefully, the complementary color of blue. Opposites, by the way, attract. And when you get, you know this from your relationships, don't you? And when you get two opposite colors on the real color wheel in different locations in the same image, they create pop and pizzazz and impact, and they sell product and they move people's emotions. There's something about these opposites that attract human eyes. They attract viewers. I would love to understand the truth about truly impactful colors. Now you'll notice when I wrote complementary colors, I spelled it this way, with an E. There are two spellings of complementary. One is the letter I, and that is like, I love your new blouse. I can't believe you bought this beautiful home. I'm complimenting your home. That is not the way it's spelled in the color world. Complementary, or two colors that harmonize with each other. They create this power and impact, spelled with the letter E, if you're ever on a game show. But that's not the mind-blowing information in this week's main lesson 3. Let's close that. This is the Munsell color system, and you were taught it no matter where you learned color, and you learned incorrectly. Now, Albert Munsell was a great guy, and he was an art teacher, and he invented the Munsell color system, which we see represented here. Even though he was born in the late 1800s, he created his system as an art teacher to help describe color. In 1903, this system, this way of describing and understanding color, is from 1903. Now, it was codified in a book that he wrote in 1905. Let me tell you what you're looking at and what you've been taught. You've been taught the 1903-05 version of color. It just so happens. It's wrong. It's out of date. It's been exploded in its lack of truth. Let's put it that way. It's close. Albert Munsell, rest in peace. It's very close. It's just not accurate. In color class, they taught you, maybe in photo class, they taught you that the opposite of blue is orange. That's a lie. It's not true. And we're going to play a little game. The opposite of red is green. No. Here's the real color wheel, and it's simplified. I promise. I promise. In true and accurate color, trust me. Boy, that's a bold statement, if not arrogant. Don't trust me. I'm going to let you trust your eyes, truly, and I'm going to let you trust the software you've been using the entire time you've been using software. Because every software program you're using has got this right. It's art classes that have been wrong. There's a disconnect. The opposite of blue is not orange. It's yellow. The opposite of green is not red. Munsell taught it was. No, the opposite of green is magenta. Now you know this intuitively. You do. When you take a photo, even back in the days of film, when you took a photo under fluorescent light that was green, how did you solve for the green? You used a magenta filter, because magenta is the complement of green. And wherever two complements tug at each other, they're not just complementary, but when they fight, when they wrestle, when they argue in the same location, when they're trying to come to a compromise, what you'll find is right in the middle, neutrality happens. Green neutralizes magenta. Magenta neutralizes green when they're put in the same location, in the same space, the same section or impact in a photograph. That's true all the way around the real color wheel. Blue skies are harmed greatly when yellow appears in the blue sky. It doesn't turn yellow necessarily, it just turns neutral. The opposite of red is cyan, C-Y-A-N. It's not pronounced cayenne. That's a red pepper, right? It's cyan, the opposite of red. Here are the three primary colors, not yellow. Red, green, and blue are the actual primary colors. Things haven't changed. It's always been true. This didn't invent itself some year beyond 1905. If I were to ask you a trick question, in what year was the Earth actually flat? You'd have to say it was never flat, Rick. I know, but there was a year that they taught that it was flat. In what year was yellow an actual primary? Never. But there were years where it was taught that. In fact, it may be the year you went to art school. I digress. The real primaries are red, green, and blue. Have you heard of RGB? RGB displays. Why are they called RGB displays? Because they have to display color truly, accurately for human eyeball consumption. Have you heard of CMY or CMYK? CMY, cyan, magenta, yellow, are in fact the opposites of the real primaries. And where red, green, and blue light come together, white happens. This is not only a religious symbol. I'm using this shape to explain that red, green, and blue combine, light combine, to make white, pure white light. And when you subtract red and green and blue light, you get no light, you get blackness. But if you only subtract red, cyan happens. If you only subtract green, magenta happens. Really, If you only subtract blue, yellow happens. And so on around the wheel. You were mistaught in art class. Just saying. Now, there have been some very impactful images that you have resonated with in the course of your lifetime. I went online because this week I was teaching in my day job, and someone said, whoa, that reminds me of the famous photo from Steve McCurry called The Afghan Girl. The Afghan Girl. One of National Geographic's most famous covers. The Afghan Girl. Let me just show you the image. Gosh, that is awesome, isn't it? It is awesome. Those piercing eyes. I mean, you cannot help but look at those eyes. And try as you must, you look at this frame and I mean, there's so much going on here, right? But I want you to notice the color. Because McCurry knew something, and he used it to his advantage. Now, that's certainly red. What's the opposite of red? Really? Really? What is the opposite of red? Really? Cyan. And by the way, you're looking at dark cyan. Cyan and red. The true complements. Creating impact. You've fallen prey to the truth about color long before you understood or even misunderstood or were mistaught about color. I'm going to open an image and let's have a little chat about color. I'm just using Photoshop to run a little slideshow for myself here, okay? That's all. Trust me, this is the human eye. Now, I do not care. You probably agree with me. We do not care if we impress manta shrimp with our photos. You can look up mantis shrimp. Mantis shrimp. You and I don't care if our photos are loved and enjoyed by mantis shrimp. Where did I pull that from? But we really care if human beings are impacted by our photos. We care about human being color. How human beings see color. Now, you and I aren't alone. We care about the human eyeball and how it reads color. We aren't alone. If I were to go back to the internet and do a search for something called CIE color, I want you to notice that in 1931, Munsell's color system was proven wrong. In 1931, it was proven wrong. You gotta be kidding. I could type 2022 as an example, minus 1931, right there in my Google search field, and get the math. 91 years ago, the Munsell color system was proven wrong. It exploded. I'll bet none of you took an art class more than 91 years ago. Why are they still misteaching you? Because art teachers, it turns out, are a somewhat lazy lot, if not unscientific. In 1931, I'll cut to the chase. There's a lot more I could tell you about this. It would take another month course. But in 1931, artists, painters, photographers, and scientists got together in France. Wouldn't you, in 1931, want to go to Paris? Hello, for an art conference? Bring it on. That's what they did. And in French, it was called the Commission Illumination, Éclairage, whatever, something like that. It just means the International Commission on Illumination. Now that's their English name, but their French abbreviation is CIE. I know, don't shoot me, I'm just the messenger. But in 1931, they said, we don't care about mantis shrimps' eyeballs, or rhesus monkeys, or dogs. We care about people. We care about people's eyes. And so they studied people's eyes. And what did they determine? Human beings can only see. Human beings can only see 3 colors. And one of them, by the way, is not yellow. In fact, they're red, green, and blue. Those are the only 3 colors that humans can see. In the back of the eye, a human eye, there are color receivers. Some of them are red light wavelength receivers. Some of them are green wavelength of light receivers. And a few of them are blue light receivers. They are officially not colored like I've done here. They're not color coded. No, in real life, they look like this. This is what the light receivers appear as in real eyeballs. There are sort of these big fat, I don't know, what would you call those? Well, they call them cones. Cones. Now, you may have heard that in science class. The big fat ones are called cones. And cones are the color light receivers. CO cone, CO color. These skinny carrot looking pieces are called rods. And rods are only black and white light receivers. There are luminance receivers. They're grayscale receivers, not color. Cones see color. All right, back to our regularly scheduled programming. Hey, I just want you to know you've only got red, green, and blue. You've only got the ability to see red, green, and blue light. You do. Yellow doesn't come into what human beings can actually see. We're going to explain more of that later. Now, if life were fair, and I hope I'm not bursting anyone's bubble here, tell the children to leave the room. Are they gone? Good. If life were fair, about a third of my cones would be red light receivers. 33.3% to be specific, right? And green and blue. You get the idea. Hey, listen, truly, life's not fair. Gosh, I hope this is not the first time you've heard that. In reality, not 33, human eyes, fully 64% of all of the cones in the human eye are red light receivers. Almost 2/3. That is not fair. Hey, when you drive to work, at least in the United States, what color traffic light do they ask us to stop at? We stop at red lights. Why did they choose red? Because someone knew the truth about this color. Red has got so much going on in the back of the eye, and then it stimulates the brain. That red, and you might have learned that in art school, is a stimulating color. Red stimulates. Red excites. We use that to our advantage, don't we? What color do they tell you to go on? The next most stimulating color, green. At about 33%. Green is the second most stimulating color. Now, I'm in the art department, and so I'm looking over here, and I have a feeling there's kind of a math problem coming up. I'm going to have to do some math, and it's kind of scary to me, but if I were to work through it for an hour or two, I would discover that there's only 4% left over. That doesn't seem fair. Well, it's worse than you think, because in the average human being, 2% of all of our all of our cones, 2% are damaged. So if you do that math, there are really only 2% remaining. That's the truth about color. As humans see it. As humans see it. I want you to know that's the truth. You can't fight the truth. And so in 1931, the CIE started to test average human eyes, and they determined all of this. Munsell was close, but no cigar. There was no yellow involved, not in how humans actually see. Now, there's a game that the eye plays with the brain. What an amazing organ the brain is, right? It never stops working for you. From the moment you're born until the moment you go to do a color lecture for BPSOP. Oh yeah, I remember where I was now. Hey, it's an amazing organ. It's an incredible organ. You and I know that. And so they researched the organ and the eyes, and they determined red, green, blue. That's it. And when they measured what human eyes could actually see, the average human eye, and the CIE gave a name to the average human eye. They didn't choose Rick Burris as the name. They could have chosen the great Brian Peterson as the name of the average human eye. His eye is nothing like average. It's incredible. But what they did is they named the average human eye the standard observer. And you'll see that if you do any more research. The standard observer could see these colors plotted out on some sort of graph. Not more math, Rick. I just want to look at the pretty colors. There it is. These are the colors humans can see. Now, are there wavelengths of light that humans' eyes don't detect, can't see? There are. And it would appear out here somewhere. There's a wavelength of light that a human can't see, and it's here. But if a human could see it, it showed up in here. And this curiously distinct shape formed itself, as elegant math often does. It formed a very cool shape. Now, I refer to this shape as the rainbow shark fin. Have you ever seen the rainbow shark fin? Most people say, I'm not sure. No. Watch me. I'm on a Mac. You may be on a PC. That's okay. We're going to learn something together. I'm going to my black Apple menu and go to my system preferences. Under system preferences, I have displays. Well, I'm only using one, my computer display right here. I tap it. I'm going to talk about color because that's the topic of lesson 3. And I would love to calibrate my display. Color calibrate my display. Welcome, Apple says, to the Apple Display Calibrator. Well, let's go on. Well, that's curious. Why, look at that. The rainbow shark fin makes an appearance because calibrated displays know the truth. They have to, don't they? Have to know the truth about human accurate vision and color perception. This shape is in your future. This shape is in your future. And it's in your very soon future. It's coming. It's coming right up. We'll stop at that for color theory. We'll stop at that for color theory. Now I'm going to open Photoshop. Let's just take a peek at some image. I just opened a recent image. And if I were to go to the image menu and go to adjustments and see how color balances, by the way, I just want to take note. We're in Photoshop. You use Photoshop, most of you do at least. You might use Photoshop in your future. Color's going to matter to you when you're here. Color matters. How does Photoshop look at color? Before I actually release color balance. come back with me. And I want you to answer this question. See if you can answer the question, what is the opposite, the real opposite, the true opposite of red? I'm helping you cheat by studying the real color wheel. Now, if it was me, I would make my own version near my desk of this color wheel, the truth of the color wheel, and I would write red, green, and blue at thirds, and I would write the opposite of blue is yellow, and the opposite of green is magenta, and the opposite of red is cyan. I would draw that out, even in black and white with a pencil or a Sharpie marker, just to have it for a reference. What is the real opposite of blue? Yellow. Well, Rick, you keep telling me that. What's the opposite of red? Really? Cyan. You keep telling me that. The opposite of green? Magenta. It's not what I was taught. I'm still debating if I'm going to trust you, Rick. But I see it. Okay, let's come on. Let's play. In Photoshop, image, adjustments, color balance. What has Photoshop been telling you is the opposite of red since the beginning of Photoshop time? What is the opposite of red? Cyan. Rick Burris is not inventing this. This is not the Rick Burris theory of color. This is true color. This is real color. What's the opposite of green? And has always been. Even when flat earthers were teaching that theory. Magenta. And the opposite of yellow is blue. Don't trust me. Trust Photoshop. If you know the real color wheel, you'll understand how to really edit and utilize color for impact, to sell your product, to impress emotions with people through their perception of color with their eyes. And you'll know how to edit color for accurate impact. That's the truth. That's the truth. I'm going to fill my screen just with old 50% gray for giggles, just so I don't have anything confusing there to stare at. And there's another adjustment in Photoshop called curves. And curves is another way to learn the truth, edit, and use the truth about color. And how do the curves in Photoshop utilize color? Red, green, blue. Not red, yellow, blue. I'm just making my case, Your Honor. Let's go to red. What's the opposite of red? Can you see it? Can you tell me? Do you know it? What's the opposite of red? Cyan. And look what happens on the red curve or the red level, whatever adjustment tool you're using in Photoshop, the opposite of red is cyan. The opposite of cyan is red. So even though this curve claims to call itself red, it's really red / cyan. What's the opposite of green? Magenta. Trust me. It's the truth. What's the opposite of blue? I'm not making stuff up. Welcome to lesson 3, all about color. Now what we're going to do is talk about how color can be communicated, how you can interact with it, and how it actually is used in Adobe Camera Raw. Now I've shown it to you here in Photoshop just so that you know that you've been using this, or ought to have been using this, your entire photo editing career. The color wheel is the key. The real color wheel is the key to understanding and utilizing accurate color. And there's a way to describe color. I'm going to click at the bottom of Photoshop on my little foreground color chip. It's currently white. I'm going to click it. And you'll see several ways to communicate about color visually, right? But look over here. You'll hear these. cyan, magenta, yellow, black, CMYK, which most impacts the print world. Here's RGB, which lots of photographers think only impact their camera, but not their photos. You know, it's RGB all the way, my friends. There's something called LAB. Look at me. LAB is the rainbow shark fin. And whether you are interacting with LAB or not, Photoshop has been. Photoshop uses LAB. Pronounced LAB, by the way, not lab. Like RGB is not Ragubba, and CMYK is not Kamika, and HSB is not Bub. It's LAB, not pronounced like a word, but in its letter forms. And LAB is perfection color. And it's the method used by Photoshop, Camera Raw, every camera to communicate from one color type to another color type. It goes through this intermediate language called the rainbow shark fin. Well, at least that's what I call it. In its real iteration, technically it's the LAB color wheel. But it's hard to talk about because nobody understands it. This is another way to describe color. I like it, and I'm going to talk about it now before I cut you loose. Hue, saturation, and brightness. What you and I call color can be broken down more specifically when we communicate with a customer, a client. Instead of saying, what color do you want? They may say, I want red. That's not the answer to my question, but they think it is. I said, what color do you want? And they told me a hue. There is a hue called red, but it's bigger than hue. Hue knew I was going to say that. It's bigger than hue because on top of the hue is a saturation variable that needs to be addressed. And saturation, you'll see when I drag side to side, visually here, it's adjusting my saturation value. Full saturation is vivid red. Half saturation is kind of pink. And zero saturation is desaturated. And that is white or gray or black. It's neutral. Desaturation, the opposite of saturation, is neutral. White, blacks, or grays. And on the real color wheel, that's what's right in the middle. You've got opposites that attract and are complementary, but if you add equal parts of those two complements, neutrality happens, neutral happens. Now the same is true when you add equal parts of a triad, red, green, and blue in equal parts also create neutrality. If humans can only see red, green, and blue, well then when those three colors are evenly balanced, neutral happens. Gray happens. A perfect balance happens. In the photography world, I think it's misnamed white balance. White balance. Well, it certainly is a white balance. It could also be called black balance because those are both neutrals. But the more preferential and accurate way to describe it would be gray balance. What am I holding? You might have heard of this. It's called a gray card. And you're going to learn this week that if you get your gray right, it gets your red right, your blue right, and your green right, when you get the gray right, perfect color happens. That's why a gray card is so important. Oh, sure, there are white balance sides to them. I never use them, because the better white balance is done with a gray card. But we're just getting started. Lesson 1. I'm going to start in the bonus videos now unpacking how this concept of truth about objective color impacts Adobe Camera Raw, how we can use it to our advantage, how we utilize the tools to get this truth manifest in our images. Who cares? Because we're dealing with humans' eyes and their emotions, humans, and their ability to take action or purchase my product or award my photo. You get the idea. Sell my photo, right? It impacts us. When we get color right, greatness happens. So for now, wipe the sweat off your brow, get a drink, take a bathroom break, breathe deeply, and when you're ready, go watch bonus video 1 for week 3. This great week on color.